This video will be about section 4.2 from the Triola stats book. It's about the addition rule and multiplication rule. So the first thing we're going to look at is what a compound event. It's any event combining two or more simple events. So for example, the first one we talk about is the probability of A or B. So this is going to be the probability in a single trial that the event A occurs or the event B occurs, or they both occur. So to find the probability of A or B, you add the number of ways that A occurs, the number of ways that B occurs, and then add in such a way that every outcome is only counted once. So the probability of A or B is that sum, but you don't want to overcount, because sometimes A or B can happen at the same time, right? A and B. So the formal rule for this is, if you have a probability of A or B happening, find all the ways that A happens, the probability, plus all the probability that B happens, and then subtract out the probability that both A and B are happening at the same time. Let's look at an example. Suppose a study of speeding violations and drivers who use cell phones produce the following fictional data. So it reads like this. It's a chart that goes across and a chart that goes down. So speeding violations in the last year are 70. No speeding violations were 685. The total users of everybody are 755. Those use cell phones and not cell phones. So what we want to do is basically look at some probabilities here. So find the probability that they use a cell phone or the person had no violation. So here's the cell phone user list, and here's the no violation list. So the probability that the person had a cell phone user is the total number of cell phone users, right? It didn't really matter if they had a speeding violation or not. It's just total number of cell phone users over the total number of people. 305 over 755. Then we do that again for the probability of no violation. That's down. So 685 over the 755. So that's the probability of A plus the probability of B, these two numbers here, if we add them up. Find the overlap. That's where you count that twice. You see the 25 plus the 280 gets the 305. The 280 plus the 405 gets the 685. We're counting that 280 twice. So we have to take out that 280 one time so that we don't count it twice. So to find the overlap would be the probability of a cell phone user and no violation. And that would be cell phone user and no violation. So they cross right here. And that would be 280 over the total, 755. So now we're going to add these two and subtract this last one off. 305 plus 685 minus 280 would be 710 over the 755. And so that would be the probability as a fraction that the person chosen from 755 people is either a cell phone user or has no violation. So with this, you always got to subtract off the the one that gets hit twice, the and, where they're both occurring at the same time, because you count them individually and then the and gets counted, twice. Okay. Let's look at some disjoint or mutually exclusive. It means that they can't occur at the same time. Okay, if you're disjoint or mutually exclusive, they don't overlap. There's no overlap. There's no and. So for example, of some disjoint sets. Randomly selecting a Ford truck on the road. No problem. The probability of that happening. And then the probability of randomly selecting a Subaru car on the road. Well, you can't select a Ford truck and Subaru car at the same time, right? So that event could not happen. There's no overlap of the probability. So if you said probability of A or B, you would have no overlap. You'd just be able to add them up. Not disjoint would be randomly selecting a Ford truck on the road, and then part B, or randomly selecting a white vehicle on the road. Okay, there is overlap, right? Because a vehicle can be both a Ford truck and white. So you'd have to take out where that both happens one time, right? The and. So whenever A and B are disjoint, where there's no overlap, kind of like the first example, that A and B becomes 0 in the addition rule. So you get this simplified version of the disjoints. So you're just adding probability in A and B together if there's no overlap. Does that make sense, hopefully? Summary: to find the probability of A or B, first associate the word or with addition. Or and addition go together. Find the value of the probability A or B, add the number of ways that A can occur and the number of ways that B's can occur, but don't overcount. You might have to subtract out that and if it exists. Okay, reminder of this complementary events. We kind of looked at it last time, but the probability of A plus its probability of its complement is equal to 1. That's the whole probability, right? Think about subtracting the probability of A and moving it on both sides over here. So then you get the probability of A complement equals 1 minus the probability of A. Vice versa, if you do it like I talked about, minus the probability of A complement, you get the other way around. It's because they both add up to 1, so you can subtract from 1 to get the other. So in this example of sleepwalking, the probability of randomly selecting someone who's sleepwalking is 0.292. Or in this way, probability of sleepwalked is 0.292. If a person is randomly selected, find the probability of getting someone who has not sleepwalked. So this is showing sleepwalked, right? Not sleepwalked. Okay, well, they have to add up to 1. So you're just going to take 1 minus the 0.92. Probability someone has not sleepwalked is 1 minus the probability someone has sleepwalked. 0.708. So you don't really need this. If you just understand that the complement of each other and the probability of the complement add up to 1, you can find that. All right, and the last part in this section is the multiplication rule. Its notation is the AND, probability of A and B. A occurs in the first trial and then B occurs in the second trial. There's another way of looking at it. Probability of B given that A has occurred. So it represents the probability of B occurring after it is assumed that A has already occurred. Okay? So here's the probability of A and B. It's the probability of A times the probability of B given that that probability of A has already occurred. Okay, let's look at an example and we'll kind of show it. Well, let's do this first here. Definitions. Two events A and B are independent if the occurrence of one does not affect the probability of the other. So if the probability of A happens and then that doesn't affect B, they're independent. Several events are independent if the occurrence of any does not affect the probabilities of the occurrence of the others. So if A and B are not independent, they are said to be dependent. If they affect the probability of one, then they're dependent on each other. Now let's look at our example where we're showing independent and dependent basically. Let's use 50 test results from subjects who use drugs from a table, and here's the shown information of the 50 test results. We're going to select two. Two subjects are randomly selected with replacement. So this with replacement means you're going to put them back. So you select them, and then you put them back. It's like drawing a card from a deck and then put it back and select another. Find the probability that the first one tests positive and the second one tests negative. All right, so we just go in order. The probability that the first one tests positive, write that out, is what? Test positive. 45 over the total. 45 over 50. Now we put it back into the pool. Put the card back. Probability that they test negative. 5 out of 50. So these are independent events. They aren't affecting each other. That was 45 out of 50 and 5 out of 50 because we put them back. So we use the formula, probability of A and B. So it's the probability of A, which was the first one, times the probability of B, given that A already happened. Okay? So for this one, it doesn't change the probability of B if we select A and put it back. We selected it out, and then we put it back. Nothing changes from the probability of B, right? It's always going to be 5 over 50 for the probability of B because we replaced it. That's the key. Replacement was the key there. So we just can multiply them together. Probability A times the probability of B, 0.09. Now without replacement, you're going to see that there's a change. The probability that tests for the first positive remains the same, 45 out of 50, right? 45 out of 50. But we don't put that person back. We keep that card out of the deck, per se. Now there's one less person in the pool, right? There's only 44 remaining positive test results, and there's still 5 remaining negative, but there's only 49 people. So now when we take probability of finding a negative test result, given we've selected a positive person, and we didn't put them back. So there's only 49 people left in the whole pool, right? Look, 44 plus 5 would be 49 up here. But still, there are 5 negative test results. So there's one less person in the pool. So now the probability of the first selection is positive would be 45 out of 50 times the 5 over 49, changing the probability slightly. It's more likely now, 0.0918. So the key here is be aware whether you're doing replacement or not replacement, because it's going to change the effect of the and the and is multiply. So summary, addition rule for the probability of A or B. The word or suggests addition. And so it'd be probability of A and B. We must make sure to check that each outcome is only counted once, and then you would add them up. Multiplication rule would be for and suggest multiplication. So probability A and B, we must be sure that the probability of B takes into the account that A has already occurred. So there may be a replacement or without replacement. Let's look at this example here. Last one. It's the McDonald's, Burger King, Wendy's, and Taco Bell. Accurate orders versus non-accurate orders. If 3 different orders are selected, we're just going to select 3 different orders from all of these orders. Find the probability they are all from Wendy's. So all we care about that they all come from Wendy's. So go in order, and it doesn't make sense that you'd put your order back. You're just selecting 3 different orders. You're keeping them in all from Wendy's. So we won't put it back. There'll be no replacement. So there's going to be some adjustments being made as we go. If we add up all these orders, something easy to do in Excel or on your calculator, there are 1,118 orders. We look at how many orders are from Wendy's. Add them up. 280. So we select our first order. Probability of our first order being from Wendy's would be 1 to the 280 out of the total 118. Now notice this. The second order has to go down by 1 because there's 1 less order from Wendy's, but there's 1 less order overall. It's like, think of it like you're selecting cards. 52 cards in the deck, I select 1 heart. There's 1 less heart in the deck, and there's 1 less card in the deck. It's kind of the same way here because we're not putting it back in. And then the probability of the third is from Wendy's, 278, 1 less than we had before, and 116. Multiply them all up together, 0.0156. That's the probability of getting a Wendy's order from all 1,118 orders by selecting one at a time like that. Okay, here's some more examples in this. Go to the page here and click with this, and you'll get a few more examples that come up about multiplication rules and addition rules. Here, what did I bring you? Here's the more example on this website here. It kind of gives you some more stuff if you want to look at it. Okay, hope that helps. Please put questions in discussion.